Have you ever wondered how a machine actually learns? Well, it's not magic, it's math. But wait, before you run from the scary formulas, you should know this. The core ideas are actually surprisingly simple. Today, we're going to open up the foundational toolkit that turns a total jumble of data into really intelligent decisions. Let's get started.
So, let's start with the biggest question of all. How does a machine actually see the world? It doesn't have eyes, it doesn't have intuition like we do. To a machine, everything, from your taste in movies to how the stock market behaves, is just data. But what does that data really look like from its point of view?
Yeah, it looks kind of like this. A giant, messy, unpredictable mess of numbers. Without any context, these values are just noise. 72, 105, 35K, what do they even mean? Are they related? Is one more important than the other? Right now, the machine has absolutely no idea.
So how in the world do we help a machine start making sense of all this messiness? Well, we give it a conceptual toolkit. Think of it as a set of simple, statistical tools that are designed to find patterns in the chaos and turn all that noise into a structured, understandable picture.
And that, my friends, is where statistics comes in. It's the language that gives raw numbers context. These tools help a model summarize huge data sets, find patterns that actually mean something, and, this is absolutely crucial, measure uncertainty so it can make predictions you can actually rely on.
All right, first up in our toolkit is the most fundamental tool of all. We need to find a baseline. Before we can do anything else, we have to understand what's considered typical in a set of data. And that tool is the mean, which you probably already know as the good old average. It's a super simple but really powerful idea. The mean gives us just one number that represents the central point of the data. It answers that really basic question, okay, what's a normal, typical value here?
Think about it like this. If you have a group of people with a bunch of different salaries, the mean just summarizes the earning level for the entire group. It boils all that different information down into a single, useful number. For a machine, this number becomes a critical reference point for what's normal. But here's the thing. Typical is only half the story. The average can actually be pretty misleading sometimes. To get the full picture, we need to know how spread out the data is. And that's where our second tool comes into play.
This tool is called variance, and it's all about stability. Variance measures how much individual data points wander away from the average. It's basically asking, how consistent or predictable is this data really? The answer to that question tells a machine how much confidence it should have in the patterns it's seeing.
Let's look at an example. So here's dataset A. See how the numbers are all kind of huddled together? They're consistent, they're stable, and they don't really stray far from their average at all. Now look at dataset B. Now here's the wild part. These two datasets could have a very similar mean, but their behavior is completely different. The numbers here are just all over the place. They're scattered, they're unpredictable, and they're way far from the center. And this just nails the point, right? Same average, totally different story. Dataset A has low variance, it's stable. A model can trust the patterns it finds there. But dataset B has high variance, it's unpredictable. This tells the model to be a lot more cautious. So you see, variance gives the mean that crucial context.
Okay, so we can find the center, and we can measure the spread. But data rarely lives in a vacuum. The real magic happens when we start to find the connections between different values. Our final tool helps us do exactly that. This tool is called correlation, and it's all about relationships. Correlation helps a model understand how two different things, we call them variables, move together. Do they rise and fall at the same time? Or does one go up when the other goes down?
This table breaks it down perfectly. You've got positive correlation. As study time goes up, exam scores tend to go up. Makes sense, right? They increase together. Then you have negative correlation. As the temperature outside rises, your heater usage goes down. One goes up, the other goes down. And of course, there's no correlation. Your shoe size has absolutely nothing to do with your intelligence. Figuring this out is huge for a model because it helps it ignore useless information.
Okay, so we have our three tools: mean, variance, and correlation. They might seem pretty simple on their own, but together they form this really powerful process for turning that initial data chaos into a structured understanding of the world. So a machine learning model basically uses these tools in a logical sequence. First, it establishes a baseline with the mean, what's typical here. Then it checks the variance. Okay, but how stable and predictable is this data?
And finally, it looks for relationships with correlation. What's connected to what?
And this isn't just theory, you know. This toolkit powers systems you probably use every single day. Recommendation engines, they use the mean to understand average user behavior, variance to account for diverse tastes, and correlation to find users who are similar to you. In finance, the mean is the expected return, variance is the risk, and correlation helps you balance a portfolio.
So the most crucial point here is that understanding these concepts really is your first and maybe most important step into the world of machine learning. It's not about being a math genius, it's about building a solid, intuitive foundation for yourself.
And having this foundation helps you avoid the most common beginner mistakes. So many people jump to complex formulas way too soon, or they look at the average but totally ignore the variance. And of course, there's the classic error of assuming that just because two things are correlated, one must be causing the other. These core ideas give you the clarity to avoid those traps.
Which brings us to the key takeaway. At their heart, statistics are not meant to be intimidating. They are simply tools for clarity. The mean tells you what's normal. Variance tells you how stable things are. And correlation explains how things are connected. It's that simple.
Grasping these three simple ideas, mean, variance, and correlation, makes the entire field of machine learning so much more accessible. They are literally the keys to unlocking the narrative that's hidden in the numbers. So, now that you have the toolkit, the only question left is what story is your data telling you?